Hi guys, G-Economics here once again. So what I'm going to do today is to run through the market structures, that's the competitive market structures, in anticipation of the Friday, date for your diary, the Friday transport paper. So what I'm going to look at is the spectrum of competition. So on the one extreme we've got perfect competition, and at the very other extreme we've got monopoly. And in between those things, or those market structures rather, we have monopolistic competition, we have oligopoly, we have duopoly, and we have monopoly. You will be expected to know about all of these, and you'll be expected to be able to represent perfect competition, monopolistic competition, oligopoly, and monopoly in the form of a costs and revenues diagram. You ought to be aware that the perfectly competitive firm is said to be a price taker, and the further we move towards the right in this instance in terms of our spectrum of competition, the further we move to the right, the more able an individual firm is to set its own price. So therefore, as we move towards the right hand side here to monopoly in its most extreme, you then move to a position of market power and being able to set your own price. So let's have a look, and I'm just going to go through these each in turn in terms of the diagrammatic explanation and analysis that goes alongside of each. So let's deal first of all with the whole concept of perfect competition. Now I guess the first thing to say about perfect competition is that it's an ideal market structure. In an ideal world, it's a structure that we would want to get to, certainly from the point of view of a consumer maximising their consumer surplus. But generally speaking, in the real world, you'd be hard pushed to find any markets which are perfectly competitive. Most textbooks will give you the sort of the same old standard examples of agricultural markets, stock markets, and the onset of the internet making competitive markets much more competitive and moving much more towards this notion of perfect competition. So, in the perfect competitive market, we have the industry and we have the firm. And one of the assumptions in perfect competition, I'm not going to go through them all, but I'm sure you've learnt them all, but one of the assumptions is that there are a very large number of sellers, there are a very large number of firms in the industry. And as a consequence of that, the individual firm doesn't have any market power, and they just have to accept or take the price which is set by the industry. And so they are said to be a price taker. So I'm going to draw the market supply and market demand curve for the industry. Price and quantity, and here we've got the supply curve, it's the markets, sorry. Here we've got the demand curve, and here we've got the supply curve. Market supply, market demand in both instances. And that yields an equilibrium at point A, which is equivalent, we're going to say, to P asterisk. Now, the individual firm, they then simply have to accept whatever price is set by the industry, because they don't have the power, the influence to determine the price themselves. And how do we show that? Well, we simply take this dashed line across, P star, and we can say, in the instance of perfect competition, we're assuming that the perfectly competitive firm can sell as many goods and services as it wants at the given equilibrium price of P star, and as a consequence the demand curve for the individual firm is, as you can see here, it is perfectly elastic. you'll find in some textbooks they refer to the fact that AR is equal to MR. Or indeed you could say that price is equal to AR is equal to MR. And you'll know that AR is also known as the demand curve. I'll give you a very quick illustration as to why P equals AR equals MR, just so that your understanding of that is absolutely spot on. So price, quantity, total revenue, average revenue, marginal revenue. So let's just say that this particular item is selling for £10 per unit. Well, if you sell 1 unit, how do you get the total revenue? P times Q. So the total revenue is 10. How do you get the average revenue? 10 over 1, 10. If we assume that we had sold 0 here, well, the marginal revenue would again be 10, because at 0 you wouldn't be earning any revenue, and then at 1 unit you're earning £10. What about quantity 2? So that would be 20. Bear in mind that's TR, total revenue. Average revenue would be the 20 divided by the 2, which gives us 10. Marginal revenue, we were earning £10, now we're earning 20. So the marginal, or the additional unit, the additional revenue per unit is £10. And hence we can say that P is the same as AR is the same as MR. Okay, hope that clears that up for you. So back to our diagrams. We are now going to add to the individual firm, which has had to accept the price determined by the industry. We're going to add a couple of the firms, the individual firms' short-run supply curves. Sorry, short-run cost curves. So we're going to add the average total cost curve, like so. ATC, sometimes it's called just the TC in some of the textbooks. And we're also going to add the marginal cost curve, the MC curve. Now, you will know that there is a profit maximizing output rule. And that profit maximizing output rule says you will maximize profits where MC equals MR. Where does MC equal MR? MC equals MR right there. And so the equilibrium price, P star, and level of output is Q star, P star, Q star. And this, ladies and gentlemen, is the long run equilibrium position for the perfectly competitive firm. Now, in an exam, obviously, you would be asked to comment on the static efficiencies. And I hope you know what those are. Static efficiencies being, on the one hand, allocative efficiency, and on the other hand, productive efficiency. A firm is said to be allocatively efficient if it's producing everything that the consumer wants, or, on our diagram, we are looking for the point at which P is equal to MC. A firm is productively efficient if the firm is producing at the minimum point on the average total cost curve. Right there. P equals min ATC. Now you can see from this long run equilibrium diagram that this particular firm is both allocatively efficient and productively efficient, because number one, it's at the minimum point on the ATC curve, which is right there. And then secondly, it's also producing at a point at which price is equal to the marginal cost of producing the very last unit. because it's the point basically at which demand and supply intersect at this point here. P equals MC. And if you've got both of those types of efficiencies together, that is known as Pareto efficiency. And when we looked at our spectrum of competition, we said Pareto efficiency, that is where, in an ideal world, that is where we want to get to. So this is the ideal position. And whenever you talk about deregulation, privatization, subsidies, well, whatever it might be in terms of transport economics and improving the competitiveness in the transport industry and in the markets, you're always focusing on, can we get to this particular long run equilibrium? How much profit is made in this market? Again, you ought to know that in the long run, firms in the long run make what's referred to as normal profits. Now, normal profits is a bit vague, isn't it? But normal profits mean it is equivalent to what other firms in the same industry make. So, if I make £10,000 profit and I'm in a particular competitive market, perfectly competitive market, and my next door neighbour, my colleague in the adjacent premises makes £10,000 profit, then we're both making normal profits. And the textbook definition refers to it as being a sum which is just sufficient to keep the current incumbents, so the people in the industry, to keep them in the industry. It doesn't attract new people in because it's not really sufficient for people to think, wow, that's massive profits, I'll have a slice of that, thank you. But similarly, the people who are in the industry, they don't think, oh, well, this is no good, I'm going to get out of this and into something else. So it's normal profit in that respect, equivalent to what others make. I'm going to try and use the same diagram here just to run through the short run position for the perfectly competitive firm. Might be better actually if I did this elsewhere on another board. Let me just see if I can move things along here and save a little bit of hassle. Right, it's probably better, I think, to do it on this board. Okay, so let's take a look then at the short run equilibrium position. So again, we're talking industry and firm. Let me just make sure that that's in shot. Excellent. So we're going to start from the long run equilibrium position. I've drawn the right diagram. So we've got the demand curve, market demand curve. We've got the supply curve. Got our initial equilibrium position. Taking that across. Putting our cost curves on. MC, ATC, AR equals MR. Okay, that's us ready to go. Right. So what would happen if there was an increase in demand for the products in this particular industry? Well, as with any product, the demand curve is going to shift to the right. So we shift it right, like so. DM2. Now we've got a new equilibrium price at P2. The firm can't do anything about this price, so they have to accept it. And so we take a dashed line across P2, and again we put our perfectly elastic AR2 equals MR2. So our perfectly elastic, in this case, in this respect, demand curve in effect. Right, so once again, referring to the profit maximizing output rule, which we talked about before, profits are maximized where MC equals MR, which is here in this instance. Take your line down, get your profit maximizing output at Q2. Now the interesting thing about this is that we've now moved from a position where we were where the costs were the same as the price. Now the cost of producing Q2, if we take a dashed line up to the cost curve, it's just right of center, right of minimum. So we take that dashed line across to our y-axis, and that's the cost. And that leaves us with this rectangle A, B, C2, P2. So basically here. And that, you'll be familiar, that rectangle then, that is known as supernormal in some textbooks, or abnormal profits. So something which monopolists would be familiar with. Now, in a perfectly competitive market, where one of the characteristics is that there's freedom of entry into the market and freedom of exit, if you're on the outside looking in at this industry, you would think to yourself, my goodness, I want a slice of this market, I'm going to get a slice of it, I'm going to take it for myself. And what would happen is that more entrants would enter the industry, and as a consequence, the supply curve would shift to the right, and you could end up all the way back at your initial equilibrium price of P star, the only difference being that you have an increased number of firms in the industry. But you would still end up back at your long run equilibrium position where, if I just flick back to the previous board, if you can see it, you'd end up back in this position on the original diagram that we looked at, the long run equilibrium, whereas this position here is our short run equilibrium position where we're making abnormal profits. So this only happens in the short run, because in the long run, people on the outside, outsiders will be looking in, thinking to themselves, I'll have a slice of this market, thank you, I'm going to enter the industry, and as a consequence the price would fall back to P star and we end up making long run normal profits again. You can also work this back in the other direction, where you consider making a loss rather than a profit. So I'm going to draw this diagram once again, and I'll just run through that one for you. So we start from the same initial equilibrium position with the industry and the firm, P and Q, and the market supply and demand curves. Oops, keep doing that, dreadful. So we've got the demand curve, the supply curve, your initial equilibrium P star. And obviously the more often you draw these, the faster you'll get at it, and just becomes old hat. Okay, in this instance we're going to consider what would happen if there was a reduction in demand. So if there was a reduction in demand, the demand curve here, D1, would shift to the left. So shifted to the left, and now we have a new equilibrium position. Equilibrium has moved from A to B, and we've got a price of P2. Now take that across to your firm, because it's a price taker, remember? So you've got P2, AR2 equal to MR2. I'm just going to take this down a little bit so don't get confused with that. That's our MC curve. Now, once again, what's the profit maximizing output rule? The profit maximizing output rule is where MC equals MR, which in this case is here. So that's the output. But again, we want to know what is the cost of that output. So we've got to take that up to the average sold cost curve and across to the y-axis, and that is our cost C2. So now we've got a large rectangular area here, and all of that area is a loss. Now the great thing, or one of the benefits I guess of perfect competition, is not only is there freedom of entry, there's freedom of exit. There are no sunk costs. And so as a consequence of freedom of exit, firms will leave the industry, the supply curve in the industry will shift left. And you could end up back here where you're making long run normal profits again. So back to our original diagram. And again, this one here, therefore, in the short run, where we're making what's known as either subnormal profit or just straightforward old loss. Again, that only persists in the short run, because in the long run, firms which are incumbents in the industry, they will just get out. Okay, I'm going to leave it at that today. I'm going to come back to this tomorrow and try and, if I can, get through monopolistic, a little bit on oligopoly, monopoly, and then some on natural monopoly as well. Okay, so I hope the revision's going well, and check out the videos and so on which are coming later in the week.